Hi, my name is Michael Johnson. I am a algebra and 8th grade math teacher at Ortiz Middle School. Today, I have the pleasure of going over volume with you guys. I know volume is reviewed in 6th grade, 7th grade, and 8th grade. But in 8th grade, the only shapes that we find volume of is volume of a cylinder, volume of a cone, and volume of a sphere. So for starters, what is volume? Well, volume is the amount of space an object occupies or that's enclosed within a container. So take this container I have. It's shaped like a cylinder. But if we wanted to know exactly how much water could fit inside of this container, we will find the volume of it. That's a prime example of what volume is. It's also measured in cubic units. So imagine before we dive into the learning, we have to nip one thing in the bud. We need to know what the difference between radius and diameter is. So when we're finding the radius would be the measure from the center of a circle to the end of the circle. Whereas diameter would be the measure from one side of the circle through the center all the way to the other side of the circle, okay? We usually find radius within our formulas for volume. So whenever you're given diameter, you would have to divide by 2. And that will give you the radius, okay? And here on my little anchor chart I created myself, I put the radius times 2 equals the diameter. So doubling the radius will give you the diameter. Dividing the diameter in half will give you the radius. Simple, right? So here we are. I've started my anchor chart for volume of a cylinder first. That's where we're starting with. So here I have my diameter, that's 12. So if our diameter is 12, that means our radius is half the diameter, which is 6 inches. Okay? Then we have the height of the cylinder at 16 inches. So, one thing that I stress with my students, the first thing when you find the volume of a cylinder, this. We don't have to memorize the formula. We don't have to memorize it because it's on our formula chart or our reference sheet that we are given on the STAR test. So when I go down to volume of a cylinder and I go over, it says V equals BH. Now when it says V equals BH, the B is capital. It's a capital letter. When it's a capital letter, that means we have to insert another formula into its place. So big B, I'm sure your teacher told you all about it. I make my students write a big B beside area because big B means area of the base. So that means we need to find the area of, well, what shape is the base? A circle. So when you go to area of a circle, pi r squared. So in the place of big B, we are going to put pi r squared. We multiply the pi times the radius and we square the radius, okay? Then we're gonna continue our formula by bringing down this h, the height. We don't want to forget about that. And I'm going to continue making this h, since I had the height in blue here, I'm going to write it in blue here. keep our color scheme going. So now we have volume is equal to pi times the radius squared times the height. So now we just input the numbers in the place that they go. Pretty simple. So pi, we all know it's approximately 3.14, but we're just going to use pi. We're going to multiply that times, what was the radius again? Half the diameter, which is 12, which is 6. So in the radius place, in place of the r, I'm going to put 6. And I'm going to square it. Then I'm going to multiply by the height, which was 16 inches. Now I multiply. So now we're ready to input our equation into the TI-84 graphing calculator. 8th grade, we use the graphing calculator. It's no secret. 6th and 7th grade, sorry guys, you still have to do it by hand. No biggie. So when I multiply pi times 6 squared times 16, it gives me 1,809 and 56 hundredths. So I'm just gonna round it to the nearest whole number, which will make it 1,810, approximately. So the volume is equal to 1,810 inches, cubic inches. Now, sometimes our answers are in a form where we still have pi on the end, where you don't multiply pi in, you just leave it like it's a variable, and that's fine. So in that case, we would just multiply 6 squared times 16, which would give us 576 pi. Cubic inches. So we have two forms of the answer. Okay? That's volume of a cylinder, sorry. Now, next is volume of a cone. So I started my volume of a cone anchor chart. I drew my beautiful cone here. That's right, beautiful. With this one, and I'm gonna get to something in a minute, but I made the radius the same radius as our cylinder. I also made the height the same height as our cylinder was. Okay, and I'll tell you why in a little bit. But let's go on. If we're finding volume of a cone, first things first, formula chart. I know we hate this thing, but guess what? You're gonna use it, okay? So when I go down to volume, the word volume, then I go down to cone. When I go over, I see V equals 1/3 BH. That's where I got this from. There's something that I told you guys earlier, and what was that? That capital B. I'm gonna box it. Does anybody remember what the capital B means? Anybody? You remember? Exactly. It means area of the base. Area of the base. And what shape is the base? Circle. I'm gonna write a circle here. So when we go back to our formula chart, where we wrote the big B beside area, and we go down to circle, pi r squared again. Let me use my reader. So pi times the radius squared multiplied by 1/3. We're gonna bring that 1/3 down, and I'm gonna do it in black. times the height, which is in blue. I'm gonna keep the color scheme going. All right. So now we have 1/3 times pi times the radius squared times the height. So now we just input our numbers where they go. So we're gonna multiply 1/3 times pi times, what was the radius again? That's right, 6. I'm gonna do it in red. Square. Oh, it should have been green, but oh well. Then times the height, which is 16. Now, when I get my graphing calculator out, I'm going to type in 1/3 times pi times 6 squared. Do not forget to square the radius. Times 16, which gives us 603 and 1900s, which when we round it to the nearest whole number is what I'm going to do today. I have 603 inches cubed, or cubic inches. If I want to have it in pi format with the pi on the end as a variable, I just multiply the 6 squared times the 16 times the 1/3. So when I multiply the 1/3 times the 16, so 1/3 times 6 squared times 16 will give us 192. So 192 pi inches cubed, or cubic inches. Both of these answers are equal. So now I can get to what I was going to say earlier. The reason I made the height and the radius the same because, do we notice something about these two formulas? I do. The only difference between them is the 1/3. So that means a cone is 1/3 of the volume of a cylinder. If and only if the radius and the height are equal. Okay? To prove that, I'm going to multiply the volume of a cone times 3. Or we could divide the volume of the cylinder by 3 or multiply it by 1/3. So I'm going to take 603 and I'm going to multiply it by 3. I get 1809 or 1809. Which is almost 1,810. So remember I rounded, so that's why our numbers are a little off. But it's 1 away, which proves what I just told you is true. Let's draw this out to make you understand. So basically, if I have a cylinder with the same height and the same radius as a cone, then 3 cones with the same height and radius combined equal the volume of one cylinder. Again, 3 cones, the volume of 3 cones with the same height and the same radius as the cylinder equal the volume of the cylinder. So the volume of the cone was 603. So 603. When you add that 3 times, it's going to equal the 1,810. And remember, 603 added to itself 3 times is the same thing as 603 times 3, which equals 1,810. It's important for us to know, okay? There are questions over that theory, okay? Don't forget it. And tell everybody I told you. One last shape left. Does anybody know what this is? It's a sphere. To find the volume of a sphere, I guess in this case, this ball, the only time you would need to calculate what's inside of this is if you want to know how much air to put in it, maybe. Other than that, I don't know why else you would need to know the space inside of this ball. But anyways, so first things first, if we're trying to find volume of a sphere, what did I tell you guys we do first? I know we're sick of it, but guess what? We're gonna use it because it helps us, okay? So, volume of a what? Oh yeah, sphere. Go over, B equals 4/3 pi r to the 3rd power. There's some things different about this. Number one, there's no capital letters other than the V, which stands for volume, which we've input a whole formula into that, okay? But there's no big B with this one. The only thing we need, and the only thing, is the radius. I'm just gonna stick with the same radius that we've been using, which is gonna be 6 inches, right? Right. So, the only thing you have to do is bring down in the radius's place that 6. So in the radius's place, I'm gonna put the 6 inches. And everything else, I'm gonna bring down beside it to multiply. So that means we're gonna multiply 4/3 times pi times the radius to the 3rd power. That's one other thing that trips up us 8th graders. We're used to the square. We're used to squaring the radius for the cylinder, squaring the radius for the cone. But once we get to sphere, we cube it. We raise it to the 3rd power. And I don't know why my students always switch this 4/3 to 3/4. Maybe because it's a friendly benchmark fraction and we're used to seeing it. And maybe that's why they want to put 3/4. But it's 4/3, okay? Just write it down right off the formula chart. Don't change it up in. But anyway. So all you have to do is calculate 4/3 times pi times 6 to the 3rd power. And we get 904 and 78/100. But I'm gonna round it to the nearest whole number, which will give us 905 inches cubed. But we have one other form, right? Remember when we don't multiply the pi and we leave the pi on the end as if it is a variable, okay? So in that case, we would just multiply the 4/3 and the 6 cubed. And that will get us 288. So the volume is 288 pi inches cubed. Both of these are equal because 288 times pi is 905. Now, even though spheres are cool, there's really not a relationship between sphere and cylinder or sphere and cone, like the cone and the cylinder had between each other, okay? So maybe we can dive into some real world problems.
Sadie used a container shaped like a cylinder to catch rainwater. The dimensions of the container are shown below. Which measurement is closest to the volume of the container in cubic centimeters?
All right, so in that problem, we had the diameter given, right? So our diameter was 12. And our height was 9. So with this one, the first thing we have to do, volume of the cylinder, I'm looking for the volume, cylinder, B equals big B, H, and remember our big B is what? I knew you got it. Pi R squared. And I'm gonna bring down that H. Well, to get our radius, how do we get our radius if we were given the diameter? Exactly. Divide by 2. You guys got it. So 12 divided by 2, everybody knows that, is what? 6. Exactly. And remember, we can't forget to do what to the radius? Exactly. Square it. Okay. Square times pi times the height is 9. When we type that into the calculator, or if we do it by hand, either or, we get 1017.8, or in 8/10. Which one is that closest to? Exactly. C, 1018. It's pretty good. Anybody have a question? Great, let's go to our next problem.
A party hat is shaped like a cone. The dimensions of the party hat are shown in the diagram. Which measurement is closest to the volume of the party hat in cubic inches?
Okay, so in this problem, first things first, were we given the diameter or the radius? Exactly, diameter. And if our diameter was, what, 6? Then that means the radius is going to equal what? Exactly, 3. And what was our height again? Does anybody remember? 9, thank you, 9. Okay. So now that we got that nipped in the bud, what are we doing here? Formula chart, exactly. So when you look on your formula chart, hopefully you have one at home, we know that the formula for volume of a cone is 1/3 times area of the base times the height. And remember that area of the base, big B, we put what in its place? Pi R squared, exactly. Bring down the H and bring down the 1/3. Now we have 1/3 times pi times the radius, which is 3 squared, times the height, which is 9. When we multiply this out, we get 84.82, which is which answer choice? Hey, pretty simple, right? We're almost done with this, guys. I mean, you've done pretty good. We have one more question to go.
A sphere and its dimension are shown in the diagram. Which measurement is closest to the volume of the sphere in cubic inches?
All right, so with that being said, what was the important information that was given? Were we given the radius or were we given the diameter? Diameter once again. So if our diameter equals 15, that means our radius is, that's a tough one. Well, 15 divided by 2 is 7 5/10. Is that correct? Right, it's correct. Of course it's correct. Now, first things first, formula, exactly. Y'all are on top of it, you're on top of it. So the formula is volume equals 4/3, not 3/4, times pi, times the radius to the what power? Exactly, to the power of 3. So all we have to do is in that radius's place, 7 5/10 raised to the 3rd power. We just bring down that 4/3 times pi. And in my graphing calculator, 4/3 times pi times 7 5/10 raised to the 3rd power is 1,767 and 1500ths, which is which answer choice, or closest to which answer choice? Jay, you got it. Ding, 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 ding. Hey, you know what, guys? I feel like we've got this volume thing in the bag. You've done a great job. Cylinders, cones, and spheres. It's pretty simple. Don't forget the special things I taught you. If you need to, create your own anchor charts, and don't hesitate to use this. There's nothing wrong with this, okay? I've enjoyed you guys. Enjoy the rest of your school year.